Good day, everyone. My name is Borys Onyshchenko. I am Associate Professor of Department of Agriculture Machinery and System Technologies, named Academic Vasilenko in National University of Life and Environmental Science of Ukraine. The thematics of my articles with co-author Volodymyr Onyshchenko and Volodymyr Nazarenko is experimental research of time for opening and closing of spray in flat and injectors nozzles. We know that the chemical protection is very important to have a good yield. Because we have a significant variety of soil, climatic condition, meteorologic factors, and another factors, a lot of weeds, a lot of disease, and if we, for example, have a good, if we don't have, for example, pesticide protection, we could lose around 80% of yield. If we don't have protection, chemical protection from the disease, we could lose around 30% of yield. That's why it's very important to have a good chemical protection and a good machine for this. The main factors in efficiency of meteorological in the yield, it's meteorological factors: wind speed, humidity, and temperature. Why? Because when we have a spraying, main materials or main instrument for chemical protection, yes, main process of chemical protection, we have creation of drops. And these drops is very sensitive to wind speed because if temperature of wind and the humidity of wind. And that's why for good efficiency chemical protection, we should have drops around 400, 500 microns and at least 100 drops per square centimeters. And we know the characteristic of nozzles. Yes, flat injection nozzle, different manufacturers, what they have. But question that I studied, it's what will be in transition period? For example, if I want to have one nozzle for one speed of wind, another nozzle for another speed of wind, because, for example, injection nozzle have a good characteristic of drift. So I mean the minimum drift, because the size of drops is around 400, 500 microns, and we have minimum minimum of drift. The flat type of nozzles have a good coverage, around 400, 300 drops per square centimeters, but they have bad drift. And we created the special combined working organ with two types of nozzles. And we need to know what will be in transition period. How much time we need for start one nozzle, and how much time we need to close another nozzle. So we need to create the schematic how we could work with two nozzles. What will be the transition period? What will be the overlapping? When we need to start one nozzle, finished another, and maybe finished another, start a first nozzle. So we need to make research of this. So first, what was done, it was literature research. What we have. So I checked the international researchers and the Ukrainian authors. So So I checked the base of Scopus And what I have on the sprayer nozzle studies. So, for example, Hater, MRKD, they studied the flow and pressure regulation of agricultural sprayers using solenoid valves. Johri, Lubert, they studied the compressive model of pesticide spray drift. So yeah, something we have. Luke and Pitla, they have studied flow, spray pattern, and droplet spectral characteristics. Yeah, but there is no answers what will be in the transitional period, what will be in the start when we have zero and the main characteristic. Yeah, what will be before zero. Martinez and other authors have studied the effect of nozzle type and pressure on spray droplet characteristic. So yes, but it's usually they usually have studied when the sprayer is in the working position. I need to know what will be before working position. Yes, we took. And other authors, they have just analyzed machine for protection, sprayers, but what will be in the transition period, no information. Polishuk have studied the substation and parameters of pneumohydraulic system for dosing and supply of working liquid. Baranovsky, Sergeyeva have studied the jet pump. So all these authors have, they have studied the sprayers, they have studied the nozzles, but what will be in the start and what will in the end, what should be the transition period between one nozzle to another, no information, no studies. So we decided to make this researches, experimental researches with two nozzles, main two nozzles, injection and flat type nozzles, and we decided how much time we need for opening and closing each nozzles, because we need to know what will be in the working position when we change nozzles in the working, no, in the stop position, in the working position. That's why we made these researches. This researches was made on the National University of Life and Environmental Science in the Department of Agriculture and Machinery. So we put the camera on the tripod and make filming the start and stop of the nozzles, the start and stop of the spraying of the nozzles, because camera have 25 frames per second. What we see, for example, the interval is 0.4 seconds. This is Lechler, this is the flat nozzle from Lechler as test 110.02. So you can see how it starts. For example, you need around 2 seconds, 0.04 seconds for opening. Yes, so it's not just. So you need some time for opening one nozzle and time for opening another nozzle. And what we see, for example, this is the 11 experimental research that we made for opening time Lechler ID injection nozzle. So you see, sometimes we have 0.46 seconds, sometimes 0.45 for 56 seconds. So less than second we need for opening injection nozzles. For flat nozzles, it's look like a quarter of second. So when we change from one nozzle to another nozzle, we need have some overlapping, because we don't need the area without spraying, because it's very bad and you have disease and another problem in this area. For example, for checking the opening time for flat nozzle, we have made around 8 experimental. And what we can see, for opening time for opening for flat nozzle from Lechler, we need average around 0.235 second, which coefficient of variation is 19.17. And for opening the injection nozzle, we need around 2 times more, 0.435 second, with variation coefficient 15.45. Closing of this nozzle is very fast, 0.08 second. So we need some time for overlapping, because we don't need the area without spraying, because we could lose the yield in this area, and it's very bad. Why we need to change the nozzle? Why we do this? Because injection nozzle have a good drops, very big drops, 400-500 microns. And this type of nozzle is perfect work with big wind speed, around 5-6 kilometers per hour. Flat nozzle have a good coverage. They have 200-300 drops per square centimeters, but they have bad work in the wind speed more than 3 kilometers per hour. So it's idea to change the type of the nozzle when the sprayer is working. In this time, in this idea, we could have good coverage when the wind speed is small, and when the wind speed is bigger than 3 kilometers per hour, we could use the injection nozzle, and this nozzle very good with drift, small drift, and good efficiency. So we have found the time for opening and close each nozzle, and we calculated, for example, for the transition time for switching from the flat nozzle to injection nozzle should be around 0.395 seconds, and transition time switch from injection nozzle to the flat nozzle should be 0.155 seconds. So that means that we should start one nozzle before the finished another nozzle. Yes, so it should be some overlapping in time to have a good coverage, because in another case we have a problem, we have not coverage zones, and we lose the yield. Thank you for attention. Waiting for questions.